Hello, algebra students. This is Mrs. Palmer, and we're going to talk about some area problems, specifically 4 different types of problems that can happen when you're being posed with something that has to do with comparing areas. The first one we're going to talk about has to do with comparing, has to do with comparing a square and a rectangle. So what we're going to do here, it says if the dimensions of a square are increased by 3 feet on one side and lessened by 2 on the other. So we know we have a square. And because it's a square, we know that the sides must be the same length. And then we're comparing it to a situation where we've increased one side by 3 feet. So you can see the increase by 3 feet and lessened one side by 2. Okay, so we've changed the dimensions. Then the new rectangle will have the same area as the original square. So now we're talking about the area and comparing the areas of these two shapes. Well, area of the square here is just going to come from x times x, so that's x squared. And area of this rectangle is going to come from x minus 2 multiplied by x plus 3. So we're going to multiply that. Now that requires a little bit more work. We've got to get this binomial multiplied by the other binomial. So we can do that with FOIL method, or just using our distribution. Plus 3x minus 2x, and then minus 6, be careful there. And then what's going to happen here is kind of interesting. You can see you have an x squared all by itself on the left and an x squared on the right. So what happens is when you subtract that x squared over, and I'm going to move up here so we have a little more room, you actually get 0 equals, putting those two terms together, x minus 6. Now, a lot of times students make mistakes with this situation, with the subtraction, and you cancel it out, and you're kind of thinking, hey, what happens? Well, what happens is you leave a 0 there. So then we can add 6 to both sides, and we get that x is equal to 6. Going back to the problem, it says to find the area of both shapes. Well, according to the problem, that should be the same. So x by x will give us 36 square feet. But also, if this was 9, 6 plus 3 would be 9 feet, and this was 4, you can see you would still get 36 square feet. So our final answer would just be 36 square feet. Okay, so that's one type of area problem that we can see. Another type is a very traditional swimming pool problem. This can come in lots of ways. It can come as a garden surrounded by a border. It can come with lots of things like that. But in this case, we have a swimming pool that's 6 feet longer than it is wide. So we know that representation very clearly, x and x plus 6. And it's bordered all around by a 2-foot wide concrete walkway, so kind of all the way around. And what you're seeing here is concentric rectangles, meaning that they're sort of proportionally shaped, and the reason is because this border is uniform all the way around on every side, so it's 2 feet. 2 feet this way, 2 feet that way. And one of the biggest challenges of a problem like this is how to define the new, larger, entire shape. Well, the way that works is if this much, you can see I'm going to make this darker, if this much is x plus 6, and I'm adding 2 that way, and I'm adding 2 that way, that's just x plus 6 plus 2 plus 2, so that's going to give us x plus 10 for the whole shape. And using the same thing up here, if this whole piece is just x, and that's a plus 2, and then another plus 2 for the other side, that's an x plus 4. So we have the larger dimensions of the whole thing put together. And what we're told in this problem is that the area of the walkway only, so the part that I'm sort of diagonally shading in right now, the walkway only is 120 square feet. So the best way for us to figure that out is if we could have the area of the whole big, huge shape minus the middle that we don't want, that I'm kind of circling, we don't really want that, subtract that away, and that should be the 120 that we want. So the area of the whole shape will be x plus 10 times x plus 4. That's everything. Minus the middle, which is x by x plus 6, should be 120. So the whole thing minus the piece in the middle, the swimming pool part, should be 120. So now as we go through and multiply, x times x is x squared, plus 4x, plus 10x, plus 40. Okay, so that's expanding that first part. Minus x squared. Oh, careful, careful here. That's going to be minus 6x. And all of that equals 120. So we definitely have some algebraic simplification to take care of here. These x squareds are going to cancel. At 4x plus 10x minus 6x, that's going to give me 8x's, plus 40 equals 120. Subtract the 40 over, 8x is 80, so that gives us x is 10. And the question says to find the area of the pool, so this means 10 feet by 16 feet. So this part is the 10 feet, this part is the 16 feet, so if I multiply that by 16 feet, I get 160 square feet for the area of the pool. Okay, you have to be careful too with what you're being asked. You could have been asked for just the dimensions of the pool, and that would be just 10 by 16. Okay, let's see our next problem. A rectangle is 8 meters longer than it is wide. Okay, we know how to write that, so I'm not really drawing that to scale, am I? Let's maybe try to get rid of that, if it'll let me. Alright, let's get rid of that and try again. A little bit more realistic, alright? So x plus 8 and x. If the length and width are both decreased by 2, so we're taking the same shape and we're making it smaller. So we're shrinking that up by 2 and we're shrinking this up by 2. So now if I have x, you can see x, and I'm shrinking it by 2, it's going to be x minus 2. And if I have x plus 8 and I'm shrinking it up by 2, that's going to be x plus 8 minus 2, which is x plus 6. So there's our new smaller rectangle. What it's telling us is that the change in area, which would be kind of represented by that amount, that whole change in area that got cut off was 62 square meters. So we're looking for the dimensions of the original rectangle. So how about we take the area of the original rectangle, we subtract the 62 that we know we should lose, and then that should get us to the smaller rectangle. Okay, so that's x squared plus 8x minus 62 equals x squared plus 6x. This is our FOIL process again, our multiplication. Okay, and we get over there. So now, hey, there's that x squared thing again that I can subtract, and that's going to cancel from both sides. I'm going to get 8x minus 62 equals, put those together, 4x minus 12. Moving my 4x over here and subtracting, I get 4x. Adding my 62 over to the other side, okay, see that? I'm going to get 40. Oops. Can you let me do that? 50. All right, so we get 50. So we can see, let me just finish that up over here. 4x equals 50. We're not going to get a whole number solution here, and that's okay. We're going to get that 4 goes into 50. 1 with 1 left over and 2, and so there's a 12.5. That's all right. So now it says find the dimensions of the original rectangle. So the original rectangle is x by x plus 8. So that's going to be 12.5 meters by, and then now we need to add 8 to that, 20.5 meters would be the original rectangle. We also could have been asked for the dimensions of the new smaller rectangle, and we would simply sub in our 12.5 into the x minus 2 and the x plus 6 figures. Okay, so that's it for this question. One more. A small rectangular city park is 20 yards longer than it is wide. All right, so it's a small park and it's 20 yards longer than it is wide. Part of the park is a shrub border that is 3 yards wide all the way around. So that's actually part of the park. So that means that there's this 3-yard shrub border all the way around. Okay. And surrounding this lawn portion. So here's our lawn in the middle. If the area covered by the shrubs, okay, here's the area where the shrubs are, is 216 square yards, what's the area of the lawn? Okay, so this is slightly different. This is just a little bit a different situation than our swimming pool situation. Here, we know this large piece, and we need to name the small lawn dimensions. Well, this is x plus 20, but I want to subtract 3 and subtract 3 more. So the whole thing is x plus 20 minus 3 minus another 3 is minus 6. X plus 20 minus 6 is x plus 14 inside. Same thing's going to happen here. If this whole thing is x minus 3 minus 3, that's x minus 6. Okay, so those are our lawn dimensions. And we're going to do something very similar. We're going to say, hey, here's the whole park is x by x plus 20. Okay, if we subtract the lawn out of the middle, there's the lawn, then that result for the shrubs should be 216, and I need to move so we have a better space when we are working this out, but that's it. So the whole thing, this is the whole thing, minus the lawn should be the area covered by the shrubs. So as we start working that out and distributing, x squared plus 20x. I'm going to give you a piece of advice. Anytime you have this situation where you're subtracting here, put some brackets around there so that you know that everything's going to get subtracted in there when you're done. We're still kind of strapped for room. 6 times 14 is 84. It's going to be subtraction. And all of that equals 216. I'm going to move down here to do this, do a better job here. So now I'm going to subtract. See, whoop, whoop, whoop. Everything changes sign in there. Minus x squared minus 14x plus 6x plus 84 all equals 216. Let's do some simplification. The x squareds cancel directly. 20x minus 14x plus 6x, that's 12x's, plus 84 equals 216. So when we subtract 84 from both sides, 216 minus 84 is 132. Oh, let me find a place to put that. Let's go up here. And now we're going to divide that by 12. So what we get when we divide that by 12 is we get 11. Okay, so now we've got our value that we need, and I'm going back to look for the question, what is the area of the lawn portion? Okay, just the lawn portion here in the middle. So that was given by the dimensions of x minus 6 by x plus 14. So I need to sub an 11 in there. So 11 minus 6 is 5 yards. And 11 plus 14 is 25 yards. So little lawn, 5 yards by 25 yards would be our answer for that one. All right, so I hope this helps. A few extra examples, and good luck with everything.